And thanks to EnergyBiz for putting on the event and for having us be a part of it. And thanks for your comments. I'm in. I'm inspired now. I'm ready to sign up and do it. It's great that Gary covered some of the benefits. I'm gonna try to stick very tightly to the topic of what's the role of technology in this, because it's interesting listening to some of the earlier panels today, and Gary's talk I think hit it on the head. Does anybody really doubt that the value's there? There's lots of things for us to debate and lots to talk about, but I hope that as you leave this day and a half, the value proposition isn't in question. And Mike, really just to your point, if you look at any newspaper today, whether it's the Wall Street Journal, the Trade Press, the New York Times, USA Today, who's a sponsor of this event, it is almost impossible to not see some topic related to smart grid, alternative energy, and what's going on. And as somebody who's been working in this space for up on 15 years, and that may make me the rookie up on the stage here, it is gratifying to see the amount of attention and the amount of visibility that the smart grid and some of the topics around energy in general that we're talking about here have had. That said, we did a survey like Gary did, and we tried to survey the country and find two people who agree on what the smart grid is, and we failed. It's a debate within the industry on what it is. Can we define it up front? Do we have to define everything it'll ever be before we get started? Which would be a very typical thing within our industry to do. If we're building a power plant, we can write a spec and very detailed requirements for what that power plant is going to do. You can talk to any utility from the utility folks that are here and ask them to see the spec that they have for cable that they buy. And I will guarantee you that a very proud utility engineer will pull out a 6-inch binder that defines everything that they need in cable. Thickness of the insulation, how much rubber, or what kind of metal, everything about cable that you'd ever want. And so we've been challenged as we talk about the role of technology of doing that same thing for the smart grid, because we don't really know everything it's ever going to be, only what we think it can be now. I believe that the smart grid will be many things, but at its core, the smart grid is a network. It's a network that will change over time. It will be different in different places. As you talk to some of the folks from overseas, they may have a greater emphasis on using this for reliability or theft reduction, whereas folks in the States here might have more of an interest in demand response, peak shaving, customer empowerment. So the smart grid isn't a thing. It's not one thing that's going to be the same for everybody who implements it. And it's not going to be the same thing today that it's going to be tomorrow. It will be a network that will evolve to support a variety of different kinds of applications, different kinds of devices, something that will allow us to leverage new things that are coming along. So it may start with smart metering, but it will grow to support some of the other applications, whether it's distributed generation, distribution automation, in-home connectivity, and other devices. And we think that there is the equivalent of a Metcalfe's law, for those of you who grew up in the tech boom or were paying attention then. There was a concept around the internet called Metcalfe's law, that the value of a network is the square of the number of users. The more users you have, the more valuable a network gets. There is some version of a Metcalfe's law for the smart grid. The value of a smart grid will be some function, some multiple of the number and different types of devices that are connected to it. So the requirements that we have now to deal with are to try to contemplate those things that we know we need to do today and build platforms that will allow us to grow into the future, things that will enable huge scale. A 5 million meter utility might end up with a 30 million node network by the time they connect all of the other things that aren't meters to the network. It has to have a very long life, something that maybe we'll talk more about, and I know everybody on this panel deals with as we do, is unlike many technologies that may have cycles of 2, 3, and 6 years, our utility customers are expecting to put out technologies that will last for 15 and 20 years. And so that really raises the bar. They have to cover vast geographies. Every time I talk to someone who worked for a cell phone company and they say, boy, we know about deploying networks, we go, you put up your network and said, if the coverage isn't good here, just move closer to the window and you'll get better coverage. I've asked any number of meters to move closer to the window, and not one yet has responded. And they have to be secure. As was mentioned by a couple of the speakers earlier today, we have to build something that's got what we consider to be a resiliency against a 40-year threat model. And that, if you talk to the security folks that you know, is a pretty tough thing to do. And oh, by the way, we have to do that all in a way that's cost-effective today. As some of the consumer advocates and other folks that spoke earlier said, I'm not going to pay any more than least cost to get it done. So I would throw out, and we don't make, at Silver Spring Networks, we don't make PHEVs, so this is not an advertisement for PHEVs per se, but it's interesting that this is a topic that comes up at almost every conference that I attend. And we started talking about PHEVs with our utility customers at an industry events about 3 years ago, and I'm pretty sure everybody thought we were crazy. That this was some sort of a futuristic George Jetson kind of a thing, and when was this ever really going to come into play in our lives, and why did we even have to think about that? And yet, every major meter manufacturer, or major automobile manufacturer, if you can still call any automobile manufacturer a major automobile manufacturer, has announced 2010 and 2011 introductions of plug-in hybrid vehicles. And I think, I forget the statistic that somebody had on one of the earlier panels that talked about 40 million cars, and that's a lot of new things. And so, this really gets to the heart of the question for this panel. What is the role of technology? And I believe that the role of technology is to provide the toolkits that turn our potential problems into opportunities and solutions. And a plug-in hybrid vehicle is a really interesting example. If you follow this at all, you'll hear smart folks who know all about the distribution grid say, I don't want plug-in hybrid vehicles, because if all those guys come home at 5 o'clock at night and plug in, that's right when my system peaks. And all of those vehicles plugging in could crash the grid. Conversely, people say, well, this is going to be great because of the V2G aspect. We're going to be able to use these vehicles as a resource to do peak shaving on the grid. And maybe, but we'll have to know where they are, when they are. It's a complicated problem. We have to know everything about that device, where it is, and what the localized conditions on the grid are. And then, of course, the last one is billing. I've said, and if anybody has heard me speak before, I apologize for repeating the story, but if Gary invites me over to dinner and I drive my plug-in hybrid vehicle and I say, where do I plug in? He might say, hey, I invited you to dinner. I didn't offer to fill your tank. And so isn't there a reason, isn't there a way that we can have that vehicle plug in, recognize that it's my car plugging in at his house, and have that bill reconciled to my bill, not to Gary's? So networks as a concept here and as a technology tool transform the PHEV from a liability to an asset. From our standpoint, and we've been pretty vocal about this, we believe in the very same open standard story that Gary just talked about, and that is that open standards, and particularly IP, is critical to make the smart grid work. Consider the power plug, an open standard for the electric grid, millions of devices and applications developed by thousands of companies over years and years. You just plug it in, and it works. Nobody had to coordinate it. Nobody had to get permission. They just did it. And within the world of networking, Internet Protocol, or IP, is the open standard for the smart grid. To the point Gary's making, utilities are pretty good at leveraging technologies that have been proven. And within networking, not much is more proven than IP. You can leverage $1 trillion of collective R&D, support any IP device or other device, including all of the web applications and things that were talked about on the earlier panels. You just plug it in, and it works. So lastly, Let's talk about value or where we are, in the market. The first thing that I would tell you, quoting one of our customers, is, the smart grid is a journey, not a destination. And that's maybe sounds cute to say and sounds easy to understand, but that's something that I think we really have to internalize as an industry. If we keep waiting for it to be done, we'll never get there. There are a lot of moving parts. It's a long-term process, and there are people inventing products, services, and devices today that we'll want to use tomorrow, and that will happen forever. We need open platforms. If we don't have them, we'll be locked into a certain narrow feature set provided by any individual vendor. I believe that open platforms for the smart grid will give birth to 1,000 new companies who are going to get venture funding or spin out of big companies today, or come out of the utilities themselves and can just plug in and work. And that helps to address an important thing that we haven't talked much about here. But because we've talked a lot about how we have to make the technology easy for consumers. I don't disagree with that, but I would argue we have to make the technologies easy for utilities too. Anybody here who's ever sold a product to a utility has probably lamented long testing cycles, long buy cycles, long integration processes. And so by having open interoperable products, we can accelerate that time to adoption. I like Gary's slide a lot. I'm going to probably steal it and rebrand it and use it at the next presentation I give about benefits. There are a ton of benefits, and they come in a number of different buckets here. Of course, all of the reliability and efficiency pieces are important. We've talked quite a bit about customer empowerment and the potential environmental impacts. There's two thoughts that I'd leave you with when it comes to benefits. The first is in defense of some of the fights that utility folks have to go through. One of the challenges we have with the smart grid is that the benefits of the smart grid do not all inure to the utility. If you went to a utility today and said, hey, I can reduce the carbon footprint of my distribution grid, until we have a carbon monetization, the utility's current business case puts the value of that at zero. It goes into that societal benefit bin that Gary had on his slide. They say, I can't sign up for that. The Public Utility Commission would love for me to say, hey, I'll pay for that because I get benefit. But the utility doesn't get benefit today. The utility's benefits around outage restoration, another example someone used earlier today, are mostly about their operational efficiencies of truck rolls and customer restorations, maybe a little bit of lost power. But the societal benefits of not being able to have your business open don't inure to the utility. So we have to be very, I think, open-minded and big picture when we talk about least cost, because it's least cost for what? What are we getting for our least cost criteria that some of the earlier speakers put out? I'd challenge to anyone in the group. I hear a lot of these numbers, as I'm sure my industry compatriots on the stage do, about how expensive this is all going to be. Billions and billions of dollars. I keep looking for Carl Sagan in the room. And I would put the challenge out to you that net of the obvious near-term benefits to utilities, those operational savings that they know they can sign up for, what is the net incremental cost of deploying, say, a smart meter system with a platform that can support the smart grid? Anybody want to guess? If you look at the public utility filings in California, Texas, and other places, it's typically less than $1 a customer a month. So when we talk about how expensive this all is, the incremental cost for deploying the platform for the smart grid is about $1 a customer a month. My good friend Jesse Burst, who writes the Smart Grid News, you may see, gave a great talk the other day. He talked about if we took everything we're talking about in the smart grid on the same kind of slide that Gary had up for the San Diego study, I mean, all the renewables and everything else, we're talking about $13 or so per household per month. So his position, and I'm, again, shamelessly stealing a line, is for about the price of a pizza, we can have the smart grid. So where we put our priorities, to a comment that one of the earlier consumer advocate folks made, I think is right. Is it worth a pizza to get the smart grid? But most importantly, and from our standpoint, I think the value of technology is that it has to be transformational. If there's a give and a take, as we've seen from telecom and internet and mobile communications and everything else, between does the technology create the application and the need and the benefit, or vice versa? And I'd say that it's both. We, as technology providers to the industry, have to provide the toolkit that allow our consumers and customers to transform the way they deliver service to do it more efficiently, more fairly, and more effectively. Thanks.